We'll be talking about fluid statics and hydrostatic pressure. My name is Melvin Cheah. The introduction. This experiment is designed to illustrate hydrostatic pressure distributions and hydrostatic forces on a plane surface. Hydrostatic pressure distributions in static fluids varies only in vertical distances and is independent of the shape of the container. The pressure is the same at all points on a given horizontal plane in the fluid. The pressure increases with depths in the fluids. Hydrostatic forces on a plane surfaces. The fluid pressure acts normal to the surface of the object and is positive in compression. The resultant moment about a specific point can be obtained from the calculated force and the center of pressure. The objectives of this experiment is to test the theory of hydrostatic for force and pressure center on a submerged plane surface, to determine if uncertainty in measurements appear to explain the inaccuracy in predicting the location of center of pressure using the equation derived from the hydrostatic theory. Methodology in this experiment: equipment, toroid device. The toroid consisted of a level, balanced weight hanger. The balance was made up the toroid, which was balanced so that the face of the toroid was vertical with no water present, and an R for mass to counter the moment caused by the hydrostatic force on the vertical face of the toroid. Precision depth measuring device. A device that enables us to take measurements of a height of a water within a tenth of a millimeter. Procedure. With the tank empty, we calibrated the balance arm so that the balance arm was horizontal. We then filled the tank so that the water level was even with the top edge of the toroid. We then added mass to the balance to level the system again. We also recorded the level of the water. This level was set to a specific height so that all other measurements would relate to this first measurement. We then choose an amount of mass to remove from the system, from the balance, and removed it. Then we leveled the system by removing water from the system. We repeated these steps for the rest of the data points. Here we have the experimental setup. On the left, we have the sketch diagram, and on the right, we have a labeled diagram. Next, we have the results from the experiment, which is the measured data on the left and the calculated data using equations on the right. Data obtained from the calculation above were used to plot a graph of MF versus MW. It shows that we have a linear relationship between the two variables. A discussion from this experiment. There is a hydrostatic pressure force acting on the circular surface of the toroid. The equivalent force will act in a direction perpendicular to the curved surface of the toroid at a location through which it acts. The center of pressure will lie on this equivalent force line of action. If the resultant force line from this hydrostatic pressure is normal to the surface of the toroid, it is also normal to a tangent line at the edge of a circle. Tangent lines of a circle always intersect radial lines extending to the point of tangency at the right angle. This means that the hydrostatic pressure force acting on the curved surface is coincident with the lines extending from the hinge to a point where the equivalent hydrostatic pressure force acts. The moment arm of this hydrostatic pressure force on the curved surface is zero, and therefore no moment is generated by the pressure force on the curved surface. Possible errors in this experiment is an error of the inherent limitation of the measuring device we use. The leveling bubble is a qualitative measurement of the angle of elevation relative to the direction of gravity. We also use tools like ruler to measure the dimensions of water level and the geometric properties of toroid apparatus. Since these errors will cause variations in an unknown direction, they fall in the category of random error, and another type of random error is incorrect eye level when taking measurements. Lastly, in conclusion, practical and theoretical hydrostatic pressures are measured using a hydrostatic pressure apparatus and calculating the resultant force acting on the plane, addition to the center of pressure PO, using some formulas, which is one of the objectives in this experiment. The experiment proves that hydrostatic forces are resultant forces caused by the pressure loading of a liquid acting on a partially or fully submerged surface. When a surface is submerged in a fluid, pressure forces develop on the surface due to the fluid. The determination of these forces is important in designing storage tanks, ships, dams, and other hydraulic structures. That is all for this experiment. Thank you very much.